5.4. We started talking about this Thursday. We're talking about how to use graphs. And most of our graphs that we're talking about are like an open box here, just kind of a corner. Where does my independent variable go? Along the horizontal axis, right? And where does my dependent variable go? Along the vertical axis here to the side. So it's important that I can differentiate between a dependent and an independent variable. Which one of these affects the other?
The independent variable.
The independent variable affects the dependent. That's how I determine what goes down here, okay? An example we used last week was sugar consumed and cavities in your mouth. Which one of those would be the independent variable? The sugar consumed can have an effect on the number of cavities in your mouth. But does the number of cavities in your mouth affect your sugar intake? No. It's a result
if your doctor
of that.
says to eat less because you have so many, but
Then your sugar consumption drops because you determined to change that. So it's an independent variable. It may lead to fewer cavities, but it's still the independent variable. It's what affects the other one. Okay? So everybody has a clear understanding of that, right? And we've talked about interpreting the graphs based on the lines that they give us. So let's look at problem number 2. You have cars passing through an intersection. Okay? Now, time and number of cars are variables. Which one is the independent variable? Does how many cars are in the road affect the time of day? No. Nothing can affect the time of day, right? It's an independent variable. It just changes on its own. Only God can change that. So time is our independent variable, and the number of cars in the intersection is our dependent variable. And you'll notice that they have the time of day marked off. They've got a period of time here marked with letters. Okay?
I think one of those would be 5 o'clock because that's the 5 o'clock rush.
Well, possibly, and that would be about halfway between 12 and 12.
12 a.m. and 12 p.m. or 12 a.m. and
What does it
12
say?
a.m.?
I don't know. It's too small on my book. I mean, on my computer, I can't read
It
it.
doesn't say anything.
Oh, yours doesn't even have time on there, does it? Okay. Mine does, so.
I think it would
I
be
might
B
be-
since that's where it's high.
Ours says hours, but
So just looking at this graph, what would you think?
I would think that C would be the busiest time because that looks like it's about noon.
I think B is because it's the
Why
highest
is
on the graph.
so why B is obviously the
Yeah, B.
busiest time. Why? What do you think's happening at point B every day?
Either they're going to work or leaving work or they have to do
People are
something.
going to work.
yeah,
Right?
Oh, I didn't see that it was on the paper.
Yeah. That's people going to work. And then notice how it drops down during the middle of the day. There's people moving around town, moving through the intersection during the middle of the day. And then it peaks again at D. What do you think's happening at D?
They're leaving.
They're going home from work.
Thank
And then
God.
look at how it begins to decline.
Yeah.
Okay? So you need to interpret each graph explaining each labeled section. That's what your instructions say. So you need to give me an interpretation of A, B, C, and D. Okay? Here's an example. For my answer key, they have A, relatively low traffic in early morning hours. Then they have B, high traffic, morning rush hour. And then they have C, increased traffic, lunch. And D, high traffic, evening rush hour. That's the kind of interpretation they're looking for. So give me an interpretation for that graph number 2 on your paper.
So what would you like